Hello guys, today I'll be showing you how to add a bunch of numbers together. These things are called series, and two very specific series, arithmetic and geometric. There's other slightly different series, but these two are the main ones I'm gonna cover for now. Infinite, in case you didn't know, it means it does have an end. So okay, first let's go over arithmetic series. So, an arithmetic series, an example would be 1 plus 2 plus 3 plus 4. Now, how would you approach this? Well, you would probably just add 1 plus 2 is 3, 3 plus 3 is 6, and 6 plus 4 is 10. But what if you had this problem? The three dots, they basically means you're adding 4, 5, 6, 7, 8, 9, 10, and all those numbers up to 100. They will always show you the last number unless it's an infinite series. Okay? How would you approach this? Well, there's a couple of ways actually. Let me on new page. So basically we're dealing with problems like this. 1 plus 2 plus 3 dot 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 plus n. N represents the last number. It could be anything. It could be 2. Even though we have 2. N just represents the last number. Okay. So let's equal this to a sum. Easy enough. And now, let's write this backwards. N plus n minus 1, because you know that's minus 1, plus n minus 2, dot dot dot, up to 1. I basically wrote this series, but you know, it's backwards. Here's your 2, and here's your 3 or whatever. But for the purpose of this, I will not include them. Okay, so this is exactly the same thing. Interesting. But the question is, why did I put it like this? Well, there's an interesting thing. If you start adding the first one with the last one, you get n plus 1. Okay. If you add the second one with the second last one, you get n plus 1. You add the third one with the third to last one, you get n plus 1. Dot, 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 dot. So basically, you have n plus 1, and how many are there? Well, there's n of them since you go up to n. For every one, there's an n plus 1. There's an n plus 1 for 1, n plus 1 for 2, n plus 1 for 3. So this would be the sum. N times n plus 1. And this is just equal to 2s. Okay, hope I didn't lose anybody. So now how do we solve for s? Well, just divide this by 2. Easy enough. You divide both sides by 2, you get s, and you get divided by 2 here. That's interesting. Let's apply it to the problem we had. So what was the formula? In case you didn't see it, let me retype it, hopefully better with me. We have n times n plus 1 divided by 2. Okay. This little bar represents dividing just so you could have an understanding. Okay, so now how many n's do we have? We have 100. So we have 100. And n plus 1? Well, 101. We divide this by 2, and we have 50 times 101, which is equals to, hopefully you guys know this, 50/50. So there, you just added 100 numbers in a few seconds. And that's the, what's a word? That's why series, or the math of series, is so good. You're adding a bunch of things and with little work. But you have to understand the concepts behind it. So okay, moving on. But what if we don't have 1 plus 2 plus 3 plus 4? What if we don't have an easy pattern like that? Well, we have, let's say, 7 plus 10 plus 13 plus 16 plus 19. Well, let's pretend it's longer. Like, you're probably gonna be able to do this in your head. But first, you gotta find out what. Well, first you gotta find out if it's an arithmetic pattern, which it is. And once you decided that, you need to know what the difference between each number is. Like, how does 7 get to 10? How does 10 get to 3? 13 to 16, 16 to 19. Well, in order for it to be a proper series, I guess, an arithmetic series, it's gonna have to have the same number. In this case, what was it? Well, hopefully you figured it out. It's a difference of 3 each time you're adding 3. Okay. So we figured out what changes. So now, so that's the first step. Actually, and let's use the thing we were using a little while ago. We add the numbers with, you add them backwards. Basically, you're multiplying times 2. 16 plus 13 plus 10 plus 7. Well, this is going to give you 26 plus 26. And you're going to do that 6 times. So you get 26 6 different times. Interesting. Using the same technique. So now that you added these two, you have 26. So an easy way to get this number is by adding the first number with your last number. And I will show you how to get this number in a little bit. But like, as you recall, this is equal to 2s since you added this 2 series. So you have to divide by 2. So 26 times 6 divided by 2. Okay. So this will be 78. But sometimes the number of numbers is not going to be so apparent. Here you could just count them 1, 2, 3, 4, 5, 6. Other times they might give you something like, I don't know, let's use the same pattern but extrapolate it. But you know, they always give you a few numbers first. 37. Well, you're not gonna know how many numbers are there, are you? Well, most people wouldn't. And if it's even longer, it'll be worse. Well, there's an easy way to actually get this. First, you gotta know what the change is. 3. And you gotta know the distance between that first number and that last number. In this case, it's 37 minus 7. What's their distance? 30. This number is important as well because you need 30 to get to 37. And as you recall, you're adding 3 each time. So this is going to tell you, well, when you divide it by 3, it's going to give you 10, which is how many numbers are after that 7. So in total, how many numbers are here? 11. 11 numbers. And what do you get when you add the first number with the last number? 44. Divide that by 2. And this will be your answer, 242. So you just added, I don't know, 11 big, somewhat big numbers. They're complete, that look completely random to the naked eye, I guess. And yeah, now let's come up with a generalization for this. Okay. So first, we start with a random number. Let's call this number A, right? And then you're adding a number, which I guess we'll represent with K. That's the change from A to that, no, from that first number to that second number. That's the change. And you basically keep on just doing this, adding 2K and 3K and 4K until you get to A plus NK. N represents the last number, I guess. Remember, in this case, there's not N numbers because 1 starts here and it ends here, so there's N plus 1 numbers. Just remember that. I could have easily just represented this as A plus K, but this seems better for me. So first, A is always 1, right? So there's gonna be how many A's? Hopefully you can figure this out. N plus 1 A's. Okay, so we figured that out. And let's see. Okay, so the next thing is, okay, add all the K's. How many K's are there? Well, if you actually factor it out, it looks a little like this. 1 plus 2 plus 3 all the way to the end. Oops. And this is basically, if you recall, it's just n plus n times n plus 1 divided by 2. Is that simple addition formula. And this is, whatchamacallit. Okay, so now let's factor it at n plus 1, and we get A plus K times n divided by 2. And I guess this is the formula that we got. But what happens if we apply the method that we got? So it's A plus NK. The first number plus the last number. So just give us 2A. And let's see. All we're doing is multiplying by, this is interesting. First number times the last number. Sorry, I'm just thinking right now. Okay. So there's n plus 1 of them, and you're basically dividing by 2. So if you have a keen eye for math or whatever, you would know that these two are the exact same things. So this is the formula that we got by deriving it, and this is more like we thought about it. So now let's do a proper example so you can get the hang of it. You don't have to memorize any formulas, more about the concept than anything. Okay, so now let's get a number. Let's say 8 plus 15 dot 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 78. Okay, so this one's a little hard, but let's try to figure it out. Okay, so first, add the first number with the last number, and that will give us 86. And how many numbers are there? 78 minus 8, that's 70. What's the rate of change? 7. So 70 divided by 7, it should always be divisible, by the way, is 10. Plus 1, that's 11. So we have 11 numbers. And remember, this is S2, so we divide by 2. So if you actually remember the 11 tutorial, it's really just 43 times 11, so it's 473. Okay. Now let's do another example that has more numbers, I guess. 2 plus 6 plus 10 plus let me think. Tick tock, tick tock, tick tock. I guess 198. Okay, so same thing. 200 times 198 minus 2, 196. 196 divided by 4 is practically like 200 divided by 4. So let's do that. That's 50. And minus 1, there's 49 after the first one, so we could just left that 50. Hopefully you guys know what I'm talking about. There's 50 numbers, and then we divide by 2, and we get, what did we get? 5,000? Interesting. So yeah, let's review this for a second. So basically, what we're doing, essentially, is adding the first term in an arithmetic series with the last term, okay? And after that, we want to multiply it times the number of terms, okay? And the way we figure out how many terms there are, we get the last term subtracted with the first term and divided by the change, which should always be a multiple. And that's going to tell us how many numbers are after the first digit, the first number. So you just add 1, and then you multiply it with the addition of the first term and the last term. So in case you figure, this is going to be your addition to a plus n3, because we have this and this. And in this case, we add this with this. And then 78 minus 8, 70. And then what's the rate of change? Hopefully you can figure it out in a quick glance. 7. 70 divided by 7. 10. 10 plus 1, 11. And then you have to remember that that's 2s. That's why you divide by 2. You just want s, the sum. You don't want two sums, you want one. So hopefully you remember this. Okay, so now to an even easier one. So let's say we're adding 1 plus 2 plus 4 plus 8 dot 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 plus 10, 24. Whoa, 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 there's no arithmetic pattern here. Well, that's hopefully, if you have a key now, you can figure out that it's doubling each time. So that means it's a geometric series. Okay. Now we can actually represent this with, we can actually figure this out easily as well. So let's do this. So it's basically just one number and it's being raised to different powers. So let's represent that number as r. R raised to the 0 plus r raised to the 1 plus r raised to the 2 dot 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 plus r raised to the n Okay, so this will also be a sum, right? So now, if you actually multiply times r, you get r raised to the 1 plus r raised to the 2 dot 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 plus r raised to the n plus 1. Because remember, multiplying everything by r, so you get r s. Okay. Now we actually subtract these two, something amazing happens. We get r divided by raised to the 0 minus r raised to the n plus 1. And that would be equal to s minus rs. And something even more amazing happens. You can actually factor out an s, get 1 minus r. So then you can have r raised to the 0 minus r raised to the n plus 1, and you could divide all of this by 1 minus r. Okay, I'm just thinking of something here. Okay, and don't think that the negative is going to be an issue. I mean, if it's below 1, this number is also going to be below 1. It's going to be approaching 0. So it's going to be positive divided by a positive. If r is bigger than 1, well, then it's kind of easy. Well, it's negative because this number is going to be big divided by a negative, so don't worry about that. So this is equal to the sum. And you can actually, let's see, I'm thinking. You can actually put, you don't have to start at 0, you can start at whatever number you want, f, first number. But for the sake of this, I'll start with 0. Because remember, any number, you'll raise it once, it'll cancel out with the rest except the last number. Okay, hope that makes sense. So now let's do some examples. 3 plus 9 plus 27 dot 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 729. What does this equal? Well, it's just gonna be, if we remember our formula, the first number minus the last number times the geometric factor. So it's going to be 3. Oh, wait. No, I didn't even start at 0, so anything to 0 power is 1. Sorry. Okay, so now, what was I doing? 1 minus 729 times, you know what, let me actually go a little bit low. They're probably not even going to ask you numbers this big, so don't worry. Okay. Minus 729. And then you're going to divide that by, what was the formula again? 1 minus r, which is 1 minus 3. So what does this give us? It gives us 728 divided by 2, which is 728. Something like that. Don't worry, I doubt questions like this will pop up in a number sense test, for example. Well, the thing is, the way this thing is used more often is for patterns that are going down. One divided by 2. So this would be the same thing, right? 1 minus 1 over 64 divided over 1 minus 1 divided by 2. So it would be 1 over 63. Oops. Divided by 1/2. Which you just flip the symbols around, flip them around and whatever, and you get 2 over 63. Wait. I did something wrong. Derp. Okay, so now we get 63 over 64, and since you're dividing by a fraction, you're actually multiplying. Sorry about the noise. People here get rowdy for football for some odd reason. Okay. And when you multiply by 2, that 64 becomes a 32. So this would be your answer. You could actually get the answer as this approaches infinity, but we won't discuss that right now. Maybe when we discuss limits or whatever. Okay, so moving on. Let's say we have a number 4, and then that number we divide that by 3. Oops. And then we divide that by 3 again, and then we divide that by 3, and so on and so on and so on, and we get 4 over 27. Well, this is basically just the same thing as this doohickey. All you're really doing is adding and multiplying an a times the r raised to the 0 or whatever. You know what? Let's just start from 4 over 3. More general. The more general, the better. So you're starting with an a, in this case it's 4, multiplying times r raised to some, I don't know, m, some random number, and then a times r raised to that m plus 1, and so on until you reach a times r raised to the last number, which would be an m. Well, essentially you're doing the same thing as this, except now you have an a. Just pretend all this. And if you start with an m, I guess this will be m plus 1, m plus 2, whatever. Still all gonna cancel out in the end, so it really doesn't matter. So it's basically still the same formula. The first one minus the last one raised to an extra power. It's gonna be the same thing. Let me think. Hold on. Hey, okay. So that a goes over here. So it's basically the same formula. Voila, it's been changed. It's at 0, and then it's at 1, at n. So now let's apply it. Hopefully you understand. So let's go. Well, let's go back to the example here. So the geometric series, it's really just somewhat of a ratio, I guess. That's how to say it. Okay, so now it's 4 over 3 minus 4 to the 27, but you raise it to an extra power. That's 4 to divide by the 8 more. Because remember, times 3, no, times 1/3, times 1/3, times 1/3. Because, you know, 3 times 3 is 9. Okay, so you have that. And then you want to divide by 1 minus the common ratio. In this case, it's 1/3. So you get 2/3 in the bottom. And in the top, you're gonna get, oh no, number. More likely in number sense says they're probably gonna give you preset and questions that have like easy answers once you actually know how to do them. In this case, it's a little more monstrous. So whatever. 27. Let me think. You know, let's actually divide this by 2 because 2 is a little nicer. And remember, raised to 1 power, that's higher. This will equal, it's a little too big, I guess. I'm just gonna go with a small number. Okay, so it's 2 minus 1/8. So 2 minus 1/8 is like 15 over 8 or something. Oops. Divided by 1 over 2, so I'm sorry if you didn't understand what I was trying to do. But hopefully you understand it's basically a ratio between the first number if you figure out if you figure out what the power is that it's being raised to, like for example here it's 1 over 2, 1 over 4, 1 over 8, 1 over 16, you're pretty much got this problem done. And remember, like I was saying, the first number minus the last number raised to an extra power. So 16, 1 over 16, and then the raised to an extra power would be 4 over 32. And then it's the difference between the first number, no, not the first, 1 minus the ratio. So maybe I should write. So first, you know what, let's just review. Okay, so basically the arithmetic formula. It's basically just that. The last number times an extra number divided by 2. This is more commonly 1 plus 2 plus 3. Okay. And basically we derive stuff from this. But this is your basic formula without any adjustments. At least remember this. And the second thing, it's basically, what was it? The first number minus your last number raised to an extra power. Or that, well, it's just two numbers. I'm just writing a sentence about it. Minus 1 minus power. And that's basically it. This is just like a ratio formula, I guess. I'm saying it's like a ratio formula because you're like dividing two things, and that's typically how they work. So yeah, if you have any questions, comments, or concerns, feel free to leave them in the comments. I'm sorry if I did a bad job, or if I didn't explain something right. Hopefully I can explain it better if you ask. So I'll see you guys next time.